In today's lecture, what we are going to do, we are going to learn upon how we are going to encrypt or how the cryptography is being applied over a plain text and how your plain text is being converted into a encrypted text, right? So, starting with slide number 2, cryptography, definition and concepts. When data is stored on a computer, it is usually protected by logical and physical access controls. However, when this same sensitive information is sent over a network, it can no longer take these controls for granted, and the information is in a much more vulnerable state. Now, what does it mean? It means that, we know that when your information is being stored over a computer or over a hard drive, it is being controlled, or the privacy is being ensured by different type of access controls. I mean to say that, like public, private, or like that. You're going to give access control to different type of people inside the organization who can access the desired level of information for the desired level of person, right? This is how you're going to protect your information when your data is being present inside the organization, or when it is residing inside some hard disk or some computer or like that. But when the same information is being traveling over a network, I mean to say that through certain sort of media, then this information would not be taking all these controls for granted. Means to say that all these controls would not be accessible over that particular information that is being traveling over a network, right? For that reason, we need to apply certain sort of mechanism in order to make that data more secure. Which is traveling over a network and it is most vulnerable and in the most vulnerable state, right? So, what is the definition of encryption? Encryption is a method of transforming readable data, called plain text, into a form that appears to be a random and unreadable, which is called ciphertext, right? Plain text, encryption, ciphertext, decryption, and again a plain text. Now see, as I already have told you different definitions of plain text and ciphertext, so I don't need to explain it again. So first of all, how the encryption can be explained. Let's suppose you have a plain text, certain sort of algos are being applied, encryption is being applied, and the resulting text would be called as your ciphertext. Now, once the ciphertext is being received at the receiver's end, that ciphertext is again decrypted by applying certain sort of algorithms, and then it is being converted into a plain text. This is how the whole encryption mechanism is being implemented. So this enables the transmission of traditional confidential information, transmission of confidential information over insecure channel without unauthorized disclosure. So by applying encryption over a text, we can transmit our data over an insecure channel without unauthorized intrusion or disclosure, right? If you can see this diagram, you might have a sender, you have a receiver, and in between you have an intruder, right? But when the information is being traveling in the form of encrypted message, this is an encrypted message that is being compromised by an intruder, which is sitting between your sender and receiver. He cannot disclose this information, or he is unable to read this information because this information is already encrypted, until and unless he possesses that particular key which is responsible to encrypt this information, right? So intruder obtains the message, but its encryption makes it useless to her, right? In the same way, without the right key, the captured message is useless to an attacker. Until and unless intruder has an access to that particular key, he would not decrypt this particular information, right? So a system or a product that provides an encryption and decryption is referred to as a cryptosystem and can be created through hardware components or program code in an application. The cryptosystems uses an encryption algorithm. Most algorithms are complex mathematical formulas that are applied in a specific sequence to the plain text. Now see, actually, what is the definition of a cryptosystem? Cryptosystem is a system or a product that is going to provide both encryption and decryption. Not we are talking about only encryption. I mean the mechanism which includes both encryption and decryption procedure, that particular system or that particular software or hardware is called as your crypto system, and that can be created with the help of hardware as well as with the help of software also. So the crypto system uses multiple type of encryption algorithms. Now, what are these algorithms? We have to learn in our next few lectures, but right now you need to understand the crypto system might be using certain sort of encryption algorithms. Now, what the algorithm is, most of the time everybody is using the term algorithm. I mean, we are using this, and this. I mean, algorithms are the complex mathematical formulas that are applied in a specific sequence to the plain text. I mean, these are the mathematical equations or mathematical complex formulas which are being applied over a certain set of text, and based on those particular algorithms, your information would be translated into a cipher text, or you may call it as a encrypted text, right? So this is the basic definition. So the crypto systems encompasses all of the necessary components for encryption and decryption to take place. Pretty good privacy. PGP is just one example of a crypto system. Now, if somebody asks you that, what might be an example of a crypto system? So that might be your pretty good privacy that I have already told you in the previous classes also. So crypto system, I mean, the good example of a crypto system is pretty good privacy is just one example of crypto system which might encrypt your data also, decrypt your data also, and also produce certain sort of keys also, right? So this is an example of crypto system. If somebody asks you that, what might be an example, so you must be telling them, and you have to Google it also at your systems, how does PGP works and all that, right? So a crypto system is made up of at least the following things. I mean, it might be a software, it might contain certain sort of protocols, it might contain certain sort of algorithms, it might contain certain sort of keys also, right? So the combination of all these things might be a single crypto system, right? So crypto definitions and concepts, most encryption method uses a secret value that is called as a key, usually a long string of bits, which works with the algorithms to encrypt and decrypt the text. Now see, the key is very important factor in any type of encryption algorithm. Okay? You need to encrypt the information, you need to decrypt the information, you must require a key, right? And I will be explaining you the key in the future also, right? The algorithm, the set of rules are also known as the cipher, dictates how enciphering and deciphering takes place. An algorithm is being used, I mean, you can define an algorithms are the set of rules which might be applied to a particular plain text to convert into a cipher text, or you may call it as an encrypted text, right? Many of the mathematical algorithms used in computer system today are publicly known and are not secret part of the encryption process. So actually the basic idea behind the whole situation is your algorithm must be remain public and your key must be remain private. I mean, it must be remain secret, right? आपका algorithm public होना चाहिए और आपकी key जो है that must be secret, and it must be only be known to the sender and the receiver. But your algorithm can be public and must be known to everybody, right? Now let take an analogy of this particular thing that I have discussed in the previous slide. If the internal mechanism of the algorithms are not a secret, then something must be. The secret piece of using a well-known encryption algorithm is the key. Now if we might have an internal mechanism of the algorithm are not a secret. Let's take an example of I mean to say that lock. As shown in the diagram, lock, I mean, everybody knows that how does a lock works. I mean, what is the internal mechanism of a lock, how it opens, how it closes. I mean, if you open it, you must easily be known that how the internal mechanism of a lock works, right? So I mean, this is open to all. The same applies to an algorithm. I mean, like an algorithm, your lock, I mean to say that internal functionality is being open to all, but make sure the secret piece of using a well-known encryption algorithm is the key. In the same way, like, but let's suppose you are going to a shop. There are many, I mean to say that locks are present, but the key is secret to only that single lock. I mean the person who possesses that particular key can open and close the lock, right? The same applies to an encryption algorithm. ठीक है जी, key जिसके पास होगी that can encrypt or decrypt the algorithm, nobody else, but your algorithm is already public, right? The internal mechanism of an algorithm is known to everybody, but key is secret and it only being present with a person who is the sender and who is the intended receiver of that particular message, right? So in encryption, the key that is called as your crypto variable is a value that comprises a large sequence of random bits, right? An algorithm contains a key space, which is a range of values that can be used to construct a key, right? So I mean to say that in any type of encryption, the key is a value that comprises a large sequence of random bits. I mean, how can you understand regarding the key? कि जी की हमारे पास क्या होती है? की आपके पास एक random set of bits होती हैं, जो आपके पास binary bits होती हैं ना, zeros and one की combination होती है, and by taking that particular key value, you are going to, I mean to say that find out the particular, I mean to say that key from the given set of values. So an algorithm might contain a key space, which is the range of values that can be used to construct a key. अब algorithm के अंदर आपके पास एक key space होता है. Now from that particular key space, you have to select a particular key for that particular algorithm. Now this concept would be more explained, would be more clear by looking on to this particular diagram. I mean, now I'm on slide number 10. If you can see in this particular diagram, you might have the keys. Keys are the combination of binary values, right? Zeros and ones or all that. Now key space is the area, the longer the key space you have, the more set of values of keys, right? आपके पास जितना बड़ा की स्पेस होगा उतनी ज्यादा कीज होंगी और उतनी ज्यादा आपकी इंक्रिप्शन स्ट्रांग होगी. आई मीन टू से दैट आपकी रैंडम कीज उतनी ज्यादा जनरेट होंगी एंड यू हैव द स्ट्रॉन्गर इंक्रिप्शन. I mean, right? And if you have the lower key space or you have the smaller key space, you might have the smaller number of keys and it easy to decrypt the smaller number of keys, right? आपके पास ये easy होगा कि आप smaller number of keys को decrypt कर सकें, right? So the larger the key space, the more variable values can be used to represent different keys, and the more the random the keys are, the harder it is to intrude to figure them out, right? I mean, if you have the larger key space, you have the larger keys and it is very difficult for an attacker to compromise any type of key. But if you have the smaller the key space, it would be easy for an attacker to compromise any type of key. So if you have the larger key space, your security is more, your encryption is more stronger. And if you have the smaller key space, it might be the possibility your encryption or your encryption is might be less stronger, right? So when the algorithms needs to generate a new key, it uses the random values from its key space. तो अब ये चीज आपने understand कर लेनी है. Key is nothing something special. It is a bit of values which might be generated from a single key space. कि अगर आपके पास एक बड़ा key space है, उसमें से randomly एक आप key उठा लेंगे, आपका system, आपका crypto system एक key select करेगा, and that key can be used to encrypt and decrypt that particular algorithm, right? So for example, I mean, now I would like to give you an example. If an algorithm allows a key length of 2 bits, right? So how many key space would be there? That would be 4. Very simple. अगर आपने binary numbers की calculations पढ़ी हैं, तो अगर आपके पास 2 bits हैं, तो 2 bits की कितनी combination बन सकती हैं? 4 combination बन सकती हैं. This means that if you have 2 bit की स्पेस, आपकी जो की स्पेस है, की लेंथ है वो 2 बिट्स है, तो आपके पास की स्पेस फॉर दैट एल्गोरिथम वुड बी 4. आई मीन मैक्सिमम कीज दैट कैन बी जनरेटेड फ्रॉम दैट पर्टिकुलर की लेंथ वुड बी 4, which indicates that the total number of different keys that would be possible, that would not be a very large key space. अब इससे क्या चीज डिड्यूस होती है कि if you have maximum number of key space is 4, अब आप उनमें से ही उन 4 की स्पेस में से ही कोई ना कोई एक की सिलेक्ट कर सकते हैं. तो डेफिनेटली इफ यू अप्लाई अ ब्रूट फोर्स अटैक, आई मीन ब्रूट फोर्स का मतलब ये होता है हिट एंड ट्रायल जो हम करते हैं. वी विल सिलेक्ट वन की, उसके ऊपर हम चेक करेंगे कि वेदर दिस इज द की, that must not be the key. फिर हम सेकंड ट्राई करेंगे, थर्ड ट्राई करेंगे और फोर्थ ट्राई करेंगे. डेफिनेटली योर की मस्ट बी वन ऑफ देम, और एक आपके पास कोई ना कोई ट्रू होगा एंड this algorithm is breakable, right? So your key space has a very important effect onto your crypto system. Larger the key space, stronger the encryption. Smaller the key space, lesser the encryption, right? So this is how your, key space are going to be, right? So a larger the key space allows for more possible keys. So today we are commonly using key sizes of 128 bit, 256 bit, 512 bit, or even 102 bits and larger. Now see, you have to be very much clear regarding the length of the key space. I mean, if a key value or the key bit length is more than 100, that would be considered as the most secured key length or key space for any type of algorithm. If your key value or the bit length is less than 100 bits, then it would be counted as the lesser amount of value. I mean to say that it would be counted as your, less secure algorithm or less secure key, right? So I mean, nowadays, whatsoever the key lengths that are being used nowadays, they are being 128 bit, 256 bit, 512 bit, or even 1024 bits and larger. So a key 512 bits would provide a 2 raised to 512 different combination. Now, can you imagine if you are going to calculate 2 raised to 512? So how many different combinations can be created for this particular value? I mean uncountable. खैर uncountable तो नहीं होंगी, but there is a very large key space would be there. So from that particular large key space, you can generate any type of key, right? So that would be unbreakable, and it would be very difficult to break that particular key. So the encryption algorithm should use the entire key space and choose the values to make up the keys as randomly as possible. And what the encryption algorithm has to do, or what it's supposed to do, it must have to select a particular key space and use it completely. ऐसा नहीं है कि उनमें से वो कोई 50 कीज उठाए, उनको यूज करे और उनको रिपीटेडली यूज करता जाए. This is again the negative effect, or the I mean to say that this is not हाईली recommendable के आप उनमें से 50 कीज को उठाएं और उन्हीं को यूज करें. तो दिस इज नॉट अ सिक्योर वे फॉर द encryption. But if you are going to use entire key space and you are going to randomize your keys as soon as possible, as much as possible, then it would make your algorithm more secure, right? Hope you are getting my point, right? So if you can see in this particular diagram, there is the key length in bits on the left hand side. I mean to say that 1, 2, 4, 8, 16, 40, 56 and so on. And on the right hand side, there is a key space. You may call it as number of possible keys that might be possible or that might be generated from that particular key bit length. अगर हम एक bit की बात करें तो maximum possible keys आपके पास क्या होंगी? 2. If we have the key bit length 2, it might be 4. If we have 4, it might be 16. If we have 8 bits, it might be 256. And if we have 16, that is 65536. And so on up to 512. Now see, the shaded area that you can see, these values are more than 100 bits. I mean key length is more than 100 bit. You can see how much longer key space you can find if you have the key length more than 100. And if you have key length is lesser than 100, it is very easy for an invader or an attacker to break up that particular key. ठीक है जी? So it has always been recommended that your key space must be more than 100 bits, right? If you can look into this particular diagram, you might see there is a time required for the decryption. This is what this table has been made from the previous table. Now let's suppose there are 4 columns: 32 key size bit, number of alternative keys, time required at 1 decryption per microseconds, time required at 10 raised to 6 decryption per microseconds. Now see, if you have 32 key size, how many bits key space can be generated? How can you calculate it? By 2 raised to 32. That is 4.3 into 10 raised to 9. How much time that might be required to decrypt this sort of situation? That might be in 1 decryption per microsecond. That is 35.8 minutes, right? At the same time, the time required at 10 raised to 6 decryption per microsecond, that is 2.15 millisecond. अच्छा जी, एक बात understand कर लें. The stronger the computation power of your system is, it would be taking lesser amount of time to decrypt that particular key, right? So I mean to say that for 32 key size, 32-bit key size, it would be required 2.15 millisecond to decrypt that particular cipher, right? I mean, if we are talking about 56 key size, it might require 10.01 hours. 128-bit key size, it might require 5.4 into 10 raised to 18 year. Can you imagine how longer this time is? I mean, if somebody is going to apply a brute force attack to compromise any key, तो उसको कितने साल लग जाएंगे? अगर 128 बिट की अगर आपके पास की लेंथ है, तो it might be taking 5.4 into 10 raised to 18 years would be required to decrypt that particular key. So it would be very difficult for a normal person to do that, or for a normal computer to do that. And the same way, if we have 168-bit length key, so it would be required 5.9 into 10 raised to 30 year. That is totally impossible to decrypt such sort of key. So we are going to increase the security of our encryption algorithm by incorporating its key size, by increasing the key size. And if you have the larger key size, you might have the larger key space, and it would be very difficult for an invader to decrypt that particular algorithm. Major symmetric key encryption ciphers, I mean to say that you have a key length in bits. अब हम आ रहे हैं कि हमारे पास एल्गोज कौन से हैं और वो कितनी बिट्स के ऊपर काम करते हैं. आई मीन वी हैव गॉन थ्रू द डैश एल्गोरिथम इन द प्रीवियस क्लासेस, इन द प्रीवियस लेक्चर्स आल्सो. आई हैव टोल्ड यू द डेटा एन्क्रिप्शन स्टैंडर्ड. तो इस तरह से हमारे पास डिफरेंट सिमेट्रिक की एन्क्रिप्शन एल्गोरिथम्स हैं व्हिच आर बीइंग अप्लाइड, एंड ऑन हाउ मेनी बिट्स, व्हाट इज द वीकनेस एंड द stronger aspect of these particular algorithms we need to discuss in this particular slide. So let's suppose we have RC4. This is an encryption algorithm, DES, triple DES, and AES. AES is the golden standard, advanced encryption standard, that is being used today for all type of encryptions, right? So let's take an example of key length. अब हम इनको characteristic wise पढ़ेंगे. Key length bits आपके पास RC4 जो है, that is using 40 bits or more, right? So I mean this is very weak at 40 bits. की strength उसकी बहुत weak है. Processing requirement is low, RAM requirement is low. Remark is can use keys of variable length, right? This is what the RC4 is. If we are talking about DES, data encryption standard, key length is 56, right? Key strength is weak. Processing requirement is moderate. RAM requirement is moderate, created in 1970s, right? This is about the DES. अगर हम ट्रिपल डैश की बात करें तो ट्रिपल डैश हैज अ की लेंथ ऑफ 112 और 168 बिट्स, राइट? द की स्ट्रेंथ इज स्ट्रॉन्ग एज वी नो दैट. अच्छा, डैश और ट्रिपल डैश में डिफरेंस ये है कि डैश आपके पास वन टाइम एनकैप्शन एल्गोरिथम चलाता है. Triple dash is actually going to repeat it for the 3 times. I mean, we are going to, I mean, if you are going to multiply 56 with 3, so it would be like, yeah, it becomes 168. So I mean, 3 times when you're going to apply dash over a single plain text, it becomes so jumbled, so transposed, so that it would be very difficult to decrypt that particular algorithm. ठीक है, आप देखिए ना, आपने एक दफा जम्बल अप किया है चीजों को, ठीक है, आपके पास सिंगल डैश आ गया, ठीक है. अब आपने उसी जम्बल्ड एनवायरनमेंट को दोबारा से जम्बल्ड अप किया सेकंड डैश के अंदर, और इन द सेम वे फिर सेकंड वाले को फिर अगेन किया 3 टाइम्स, तो इट वुड बी टोटली चेंज. इट वुड बी वेरी डिफिकल्ट टू फाइंड द plain text from the given text. So triple dash is the advanced version of dash, which might be using 168-bit key lengths, right? So it is a stronger one. It has a processing requirement bit high, right? This is the I mean to say that negative point. RAM requirement is moderate, right? Applies to dash 3 times with 2 or 3 different dash keys, right? Now come to the AES. Now AES would be using 128, 192 or 256 bits of key length, right? This is the golden standards that might be used today for any type of encryption. Key strength is very strong, right? Processing requirement is low, RAM requirement is very low, and remarks are today's gold standard for symmetric key encryption. So this is the best standard that is being used for any type of encryption nowadays in the world, right? We are coming towards the Kirchhoff's principle. Auguste Kirchhoff published a paper in 1883 stating that the only secrecy involved with a cryptography system should be the key. He claimed that the algorithm should be publicly known. He asserted that if security were based on too many secrets, there would be more vulnerabilities to possibly exploit. Now, see, according to Kirchhoff's law that was being given in 1883, what he said that algorithm must be public and your key must be private. ठीक है जी, तो ये उसका कॉन्सेप्ट था कि जी पब्लिक एल्गोरिथम आपका पब्लिक हो, एवरीबडी कैन कंट्रीब्यूट इनटू दैट एल्गोरिथम, एवरीबडी नोज अबाउट दैट एल्गोरिथम, हर कोई उसमें कंट्रीब्यूट करे, लेकिन जो आपकी की होनी चाहिए ना, दैट मस्ट बी सीक्रेट एंड ओनली बी नोन टू सेंडर एंड रिसीवर. दैट्स व्हाट द मेन I mean to say that claim of Kirchhoff's, right? So cryptographers in the private and academic sector agree with Kirchhoff's principle because making an algorithm publicly available means that many more people can view the source code, test it, and uncover any type of flaw or weakness. It is the attitude of many heads or better than one. Once someone uncovers some type of flaw, the developer can fix the issue and provide society with a much stronger algorithm. Right now, see, I would like to say that कि जी ये वही डिस्कशन या वही डिबेट है जो हमारे पास ओपन सोर्स और लाइसेंस सॉफ्टवेयर की होती है. I mean, what the open source says the code is available to everybody can contribute, so that the application can get more stronger and stronger, so that it must be available to everybody. There is no any restriction to access the code, and that is freely available over Git or like that, right? But when we are talking about the licensed product, you need to purchase a license of that particular product, and there is no code available for the I mean to say that licensed product, right? The same applies over here. The someone many heads are better than the one. I mean to say that many people who are contributing are much better than a person who is single contributing to that particular product. So that's what the same applies to the I mean to say that Kirchhoff's principle. So that algorithm is known, available, and the code is everybody can contribute to that particular algorithm, but only your I mean to say that keys are secret, right? नॉट एवरीवन एग्रीज विद दिस फिलॉसफी. अब ये तो आपके पास एक स्कूल ऑफ थॉट हो गया कि जी आपका एल्गोरिथम पब्लिक होना चाहिए जो किर्चॉफ ने कहा, और की सीक्रेट होनी चाहिए. बट गवर्नमेंट अराउंड द वर्ल्ड क्रिएट्स देयर ओन एल्गोरिथम्स दैट आर नॉट रिलीज्ड टू द पब्लिक. देयर स्टैंस इज दैट इफ अ स्मॉलर नंबर ऑफ पीपल नो हाउ द एल्गोरिथम एक्चुअली वर्क्स, then a smaller number of people will know how to possibly break it. So cryptographers in the private sector do not agree with this practice and do not trust algorithm they cannot examine. So it is basically the same as the open source versus compiled software debate that is in full force today. Now universities, colleges or schools or research organization ने तो इस चीज को accept किया कि your algorithm must be public, everybody can contribute and can do more to that algorithm. But the organization which are secret organization, I mean let's suppose NASA, CIA, or these type of organizations which are very secure and they do not want to open up their secrets to all the world, to the international world. What they said that we are not agreeing with this particular concept. According to them, the algorithm must be private and it must not be made public. The reason is less number of people knows about the algorithm, less number of people must know that how to break it. I mean, obviously this is true. So what they thought, they think that whatsoever the algorithm we will design, we will not make it public, but I mean they must be private to set of people who only works inside the organization. That's what their stance is, right? So it's basically the same as the open source and compiled software debate that was being used today, right? So strength of the crypto system, from where the strength is coming, the strength of an encryption method comes from the algorithm, the secrecy of the key, the length of the key, initialization vector, and how they all work together within the crypto system. अच्छा जी, अब डिबेट आ जाती है कि जी स्ट्रेंथ क्रिप्टो सिस्टम, स्ट्रॉन्गर क्रिप्टो सिस्टम कौन सा होता है. आई मीन हाउ यू कैन मेक योर क्रिप्टो सिस्टम स्ट्रॉन्गर. आई मीन यू कैन ऐड strongness inside your algorithm by adding method comes from the algorithm. एक तो आपका algorithm secure होना चाहिए. Second one is your the secrecy of the key. It must be ensured, your key must be secret. The length of the key, it must, you have a bigger key space or the larger key space. The initialization vector, this is a value that is being added in a very initial start of your system, right? We shall be discussing in the future, but right now you need to understand initialization vector is some value that is being added at the start of any program, and how they all work together within the crypto system, and lastly how they all work together to form your crypto system more stronger. So all these things are going to contribute in order to make a good crypto system, or powerful crypto system. So when strength is discussed in encryption, it refers to how hard it is to figure out the algorithm or a key, whichever is not made public. Now see, so whensoever we are going to discuss strength of a crypto system, अगर हम discuss करें कि जी हमारे पास crypto system की strength क्या है, तो कितना मुश्किल है किसी एल्गोरिथम और की को डिक्रिप्ट करना या कॉम्प्रोमाइज करना, that would be the strength of any crypto system, right? whichever is not public, ठीक है? अगर आपका एल्गोरिथम पब्लिक नहीं है या आपकी की पब्लिक नहीं है, दोनों में से जो भी पब्लिक नहीं है उसको डिक्रिप्ट करना या उसको कॉम्प्रोमाइज करने को हम क्या कहेंगे कि that would be the strength of that particular crypto system, right? So strength of an encryption method correlates to the amount of necessary processing power, resources, and the time required to break the crypto system or to figure out the value of the key. Right? Breaking a crypto system can be accomplished by a brute force attack, which means trying every possible key value until the resulting plain text is meaningful. Depending upon the algorithm and length of the key, this can be an easy task or one that is close to impossible, right? I mean to say that how you are going to create or how you're going to calculate the strength of any encryption method, that might relate to the amount of necessary processing power. Definitely you're going to decrypt the algorithm by using any computer machine. So computer machine's processing power, its resources, and time required to break the crypto system to figure out the value of the key. These are the very important factor for any strength of a encryption method, right? And breaking a crypto system, how can you break a crypto system? You have to apply a brute force attack, hit and trial method, you may call it as, which means that you try every possible key value. Let's suppose if you have a larger or a smaller key space, you have to use each and every key space, or sorry, key value inside that particular key space. Any one of the key would be the key that might be used in that particular encryption method. So अगर आपके पास 10,000 values हैं key space के अंदर, तो उनमें से कोई एक ना एक key तो ऐसी होगी ना जो यूज हुई होगी, तो you have to use brute force attack, try hit and trial method in order to discover the exact key that might be used inside your encryption method. So this is how you're going to break any crypto system. So depending upon the algorithm and the length of the key, this can be an easy task or one that is close to impossible. It totally depend upon how secure your algorithm is, right? And how longer the length of your key is. How longer the key space is, and how secret your algorithm is. Based on that, we can decide that, okay, is it easy task to compromise your algorithm, or it is a difficult task to compromise your algorithm, right? Either it is a possible or an impossible task, right? So the goal when designing an encryption method is to make compromising it too expensive or too time consuming. Another name for a cryptography strength is work factor, which is an estimate of the effort and resources it would take an attacker to penetrate a crypto system. अब जो term हमारे पास use होती है, that is called as work factor. Now work factor is the definition which is an estimated effort that is being required to break any particular crypto system. That's what we can call it as a work factor. Right? So important elements of encryption are to use an algorithm without flaws, use a larger key size, use all possible values within the key space, and to protect the actual key. If one element is weak, it could be the link that moves the whole process. Now see, I mean to say that if we are talking about any type of encryption method, algorithm, how can you ensure this, strength of any algorithm, right? Your algorithm must be without flaws, right? It might be using a larger key size, ठीक है, आपका की साइज लार्जर होना चाहिए, आपका एल्गोरिथम फ्री ऑफ फ्लॉ होना चाहिए, you have to use all possible values within the key space. एक तो आपके पास जो भी key space है उसके अंदर सारी की सारी values आपने randomly use करनी है. You do not have to use a set of key spaces or the set of keys which you are going to repeat again and again. That might not be the case. And to protect the accuracy. And once you got a key, you have to protect it. You must not have to tell to any third person who is not legitimate or who is not liable to read that particular information, right? So if one element is weak, it could be the link that moves the whole process. अब इनमें से ऊपर वाली चीजों में से if any one of the link is weak, I mean any one of the characteristic is weak, then it means that your whole process would get down or would get compromised, right? So even if a user employs an algorithm that has all the requirement for a strong encryption, including a larger key space, larger random key value, if he shares his key with others, the strength of the algorithms becomes almost irrelevant. अब इसका मतलब ये है कि I mean एक यूजर ने एक बहुत ही अच्छा एल्गोरिथम यूज किया, he used a larger key space, he has done he has taken each and every layer to secure any type of plain text or I mean encrypted text or like that. But at the end of the day, he has given that particular key, the key for which your data is being encrypted and decrypted to any person, then the whole process will go in a van. I mean, there is no use of that. आपका सारे का सारा data decrypt हो जाएगा because you already have given that particular key to some other person, right? So this is how you are going to implement security. We don't have time, तो मैं ज़्यादा टाइम नहीं लेना चाह रहा आप लोगों का. Okay, confidentiality. अब इसकी हर एक एग्जांपल मैं आपको बता रहा हूँ. Confidentiality renders the information unintelligible except by authorized entities. I mean nobody else can read your information. It must be only for the authorized employees. This is what the confidentiality is. I mean nobody can read the information. Unauthorized person. Integrity is data has not been altered in an unauthorized manner since it was created, transmitted, or stored. I mean wherever your information is being traveling, it must not be intruded or altered by some unauthorized user over a network. This is how you're going to ensure the integrity of your information. Third thing is authentication. This is going to verify the identity of the user or a system that created information. I mean, you are going to verify the identity of the person or a user who has created certain set of information, whether the person who is sending the message is an authenticated user or not. This is how you're going to ensure the authentication inside your crypto system. Authorization upon proving identity, right? The individual is then provided with the key or password that will allow access to some resources. I mean, identity has been ensured that this is the right person, this is an authorized person, then we are going to say that we are going to provide him certain sort of user ID and password, and then by using that particular user ID and password, he would be logged into the system. That's what you can call it as an authorization. And non-repudiation is ensure that the sender cannot deny sending the message. I mean, I have told you that repudiation is, I mean, somebody is going to deny that particular message by sending that particular message. Now see, I mean, if I'm going to send a message to anybody and tomorrow I would like to say that I haven't sent that particular message, this is what the repudiation is. And non-repudiation is we need to ensure that the sender who has sent the information, tomorrow he must not say that I was not responsible to send that particular message. This is what the non-repudiation is. So all these are the 5 services of crypto systems that we are going to ensure by implementing crypto system inside our application, right? So I need to give you an example. If David sends a message and then later claims he did not send it, this is an act of repudiation. I mean, डेविड ने मैसेज सेंड किया और बाद में वो क्लेम कर रहा है कि मैंने सेंड नहीं किया. इसको हम क्या कहेंगे कि ये रेपुटेशन बिहेवियर कर रहा है, ठीक है, शो कर रहा है. बट व्हेन अ क्रिप्टोग्राफी मैकेनिज्म प्रोवाइड्स अ नॉन रेपुटेशन, द सेंडर कैन नॉट लेटर डिनाई ही सेंड द मैसेज. ही कैन ट्राई टू डिनाई इट बट द क्रिप्टो सिस्टम प्रूव्स अदरवाइज. नाउ सी, नॉन रेपुटेशन का मतलब ये है कि क्रिप्टोग्राफी हमारे पास नॉन रेपुटेशन मैकेनिज्म को इंश्योर करती है. वो कैसे करती है? आई मीन लेट्स सपोज इफ आई एम गोइंग टू सेंड सम इंफॉर्मेशन थ्रू अ व्हाट्सएप अगर मैं कोई मैसेज सेंड करता हूं तो अल्टीमेटली दिस इज टोटली इनक्रिप्टेड एंड इट वुड बी इजीली कि कल को अगर वो मैसेज आप कहते हैं कि जी मैं उसको डिलीट भी कर देता हूं. लेट टेक एन एग्जांपल कि मैसेज मैंने सेंड किया, वो आपने पढ़ा और उसके बाद उसको मैंने डिलीट कर दिया. लेकिन इन फ्यूचर इफ समबडी वांट्स टू I mean investigate कि this message was sent by me or not, and in future I'm going to deny it कि no, I was not the sender of this message, but by applying cryptography, it is going to ensure that the person who is sending the message must ensure his presence, or his, he says that okay, this is the person who is sending that information. This is what, how you are going to ensure the non-repudiation inside your crypto system by applying cryptography, right? This is what the concept of non-repudiation and repudiation is, right? So let's suppose now we are going to explain each one of them individually. Suppose your boss sends you a message telling you that you will be receiving a raise that doubles your salary. The message is encrypted, so you can be sure it really came from your boss. Let's suppose you are getting some authenticated message from the head of your organization, and he's saying that your salary is doubled. But how can you ensure that this message is secure, or to say that confirm authenticity? How would you ensure that authenticity? Because this email was encrypted, right? When it is encrypted, this means that the authenticity is being ensured by this particular crypto system or encryption. Now, someone did not alter it before it arrived at your computer. This is what you can call it as an integrity. On the way, your information must not be modified. This is what you can call it as an integrity of the information. Integrity of the information is being ensured. Third point is no one else was able to read it as it traveled over the network. This is what the confidentiality is. To say that nobody else is being reading this information. This is how you are going to ensure the confidentiality of your information. And finally, your boss cannot deny sending it later when he comes to his senses, non-repudiation. अब ऐसा भी नहीं हो सकता कि सुबह उठ के दूसरे दिन आपको आपका बॉस ईमेल कर रहा हो कि नहीं ये मैंने सेंड नहीं की, because he has sent through a particular system or by using encryption, so he will never deny that particular message. या non-repudiation behavior वो शो नहीं कर सकता, ठीक है? This is how you are going to ensure all these parameters in any type of crypto, all these services in any type of crypto system, right? So how these services are being beneficial for what type of organization? I would like to read it for you. For the military and intelligence agencies are very concerned about keeping their information confidential. They require, so they would choose encryption mechanisms that provide a high degree of secrecy. For the military or secret organization, they don't want any type of integrity or like that. They need कि जी उनकी information confidential होनी चाहिए, ठीक है? They need confidentiality inside their data so that no else person or no third person can read their secret information, right? So when we are talking about financial institution, they care about for confidentiality. They might care, but they also care about the integrity of the data being transmitted. So the encryption mechanism they would choose may differ from the military encryption method. अब देखें, अगर कोई बैंकिंग सेक्टर है या कोई फाइनेंशियल इंस्टीट्यूशन है, they might more concerned about the integrity feature of the message, integrity of the information rather than some other features. Definitely other features are also very important, but they are more concerned about the integrity, because if somebody is going to modify information in the bank, अगर किसी के 10 millions लिखे हुए वो 100 millions हो जाते हैं, तो definitely they would ruin the bank. वो पूरे के पूरे बैंक को खत्म कर सकता है या उनको लॉस कर सकता है, ठीक है? So integrity, no unauthorized user can modify the information. That is going to be ensured by integrity, and financial institutions are more concerned regarding the integrity of the information, right? अगर हम तीसरी की बात करें, so if messages were accepted that had a misplaced decimal point as 0, the ramification could be far-reaching in the financial world. अगर आपका एक 0 प्लस या माइनस हो जाता है, तो it would be a disaster for that financial institution, right? And finally, we have the legal agencies may care most about the authenticity of the message they receive. Rather than the other. अब legal agencies, अगर आपके पास कोई court of law है, they would be finding the document that it must be coming from the legitimate organization. ठीक है जी? If information received ever needed to be presented in a court of law, its authenticity would be certainly be questioned. Therefore, the encryption method used must ensure authenticity, which confirms who sent the information. See, let's suppose somebody from someone from student is going in the court of law, and they are going to say that they haven't received their degrees illegal or like I mean that is fake or like that. Now who is going to ensure that particular thing? I mean अगर आपके पास आपकी ऑर्गेनाइजेशन है वो कहती है कि जी आप अपने डॉक्यूमेंट्स की वेरिफिकेशन करवाएं, ठीक है, I mean you have submitted your document, right? Even that is a legitimate document, each and everything is fine, that is a photocopy, even आपने original भी उनको दिखाया, लेकिन how they are going to ensure that? They are going to say that you have to do this verification from HEC. Now HEC is a legitimate organization in Pakistan who is going to ensure the authenticity of the documents regarding the universities and all that. तो उसको ensure अगर वो HEC से उसको stamped है वो document आपका, तो it means that authenticity of your information is being confirmed. So I mean from organization to organization these crypto system services are being varied. For financial organization integrity is more important, for military organization your confidentiality is more important, and for the legal or court organization authenticity is more important. So this is how these services are being implemented in different type of organization.